11.6 is trig word problems again, but level 2, they get a little bit harder. We're going to have two triangles put together here. It says a boat is heading towards a lighthouse. So picture that. You've got some lighthouse, which is going to be a vertical, and you've got some boat. It's going in towards the lighthouse. The beacon light is 150 feet above the water, so that's our vertical. From point A, so let's call this A. The boat's crew measures the angle of elevation to the beacon, which is just the top of the lighthouse, to be 12 degrees. So where they're at here, they're measuring this to be 12 degrees. I'm just going to put an arrow here. And then they're getting closer to the lighthouse because we said they're coming in, right? They're going in towards. Then they measure the angle of elevation a second time from point B, so just make it somewhere closer to the lighthouse, to be 21 degrees. So still measuring up to here. So the angle became bigger because now this is steeper. Looking up to it because now they're getting closer. Find the distance from point A to point B. So they want this. All right, the problem here is if this were my triangle, that is definitely not a right triangle. So I can't just do some kind of trig function with this. What I need to look at is somehow using either the smaller right triangle or the entire right triangle. And so let's just think about how we would find only this. Well, if I could find this whole thing from here to here, I could, and then find this from B to the lighthouse, I could subtract them to leave me with this. That's what I'm going to have to do. So how can I find this entire thing? Well, I've got this angle here is 12 degrees. I've got its opposite side. I would need its adjacent side. So I'm going to do tangent of 12 degrees would be 150 over x. Swap these. So x is going to be 150 divided by tangent of 12. Okay, that is 705.69-ish. I'm going to leave that in my calculator though. So that's from here to here. All right, now I'm going to find just from B to here. So the only thing that changes is my angle of elevation. Now I'm going to have tangent of 21 degrees. Opposite still the lighthouse. Over, call it x, call it y, whatever you want. Swap these. So really y is going to be 150 divided by tangent of 21. And it's 390.76 from here to here. So now subtract the 705.69 minus the 390.76 to leave you with this. So I'm going to go up here, steal this answer, minus, go up here and steal this answer. So nearest foot would be 315 feet. All right, number 2. Again, a boat is heading towards the lighthouse. When Charlotte is watching from a vertical distance of 137 feet above the water. So let's think about that. So she's up in the lighthouse, 137 feet from the water. Here's the boat. I'm sure they're going to be doing something. I'm looking up her. Now, I guess the vantage point changes. Now, Charlotte, we're talking about her being up here. So Charlotte is here, looking down. She measures an angle of depression to the boat at point A to be 11 degrees. So angle of depression would really be here, but we're going to put it inside the triangle here. And then later time, she takes another measurement, finds the angle of depression to the boat now at point B. So move it in closer to the lighthouse. That would be this, which would now put it in here to be 47 degrees. So really this became just like problem number 1. Find the distance from point A to point B. This is what we want to know. Okay, so again, I've got an opposite over an adjacent. So it'd be tangent of 11 degrees equals 137 over, I'll call it x. Swap these. So x is going to be 137 divided by tangent of 11. That's 704.8. Okay, we'll have to subtract that from this here to here, and that's going to be found by having tangent of 47 equals 137 over y. Swap. So take 137 divided by tangent of 47, which is about 127.75. So take this minus this, and that would be 577 feet. And number 3. So this is kind of confusing. Michaela spots an airplane on radar that is currently approaching in a straight line, and that will fly directly overhead. So that means she is here on the ground. I guess it doesn't tell us that, but that's what it means. So she's on the ground. She's looking up. It will. Okay, so the airplane is, let's say, over here. Here's the airplane. It's going to fly this way directly over top of her. Okay. The plane maintains a constant altitude of 5,750 feet. That means from where the plane is at, its vertical distance, its height is 5,750 feet. So even as it goes over top of her, it's still going to be 5,750 feet above her head. Michaela initially measures an angle of elevation to be 16 degrees. So let's call this point A. She's looking up to it, so this is 16 degrees. Later time, she measures an angle of elevation of 31 degrees. So the plane has come closer. So let's say here, call that point B. And then we've got 31 degrees. Find the distance the plane traveled from point A to point B. Okay, so what I'm going to do to make this look a little nicer is to drop down an altitude here as well. So now you should see this makes a little right triangle, and then we've got this other medium-sized right triangle. Can you see that? And so what I want to do, I'll also drop this down. So I'm just trying to find A to B. If I use the first triangle I drew, I can find this whole distance from Michaela to where the plane started, the horizontal distance. So from 16, I've got opposite over adjacent again, that would be tangent of 16 degrees equals 5,750 over x. Swap, so x is going to be 5,750 divided by tangent of 16. That is 20,052.63. Okay, then I'm going to find, I'm going to use this triangle to find from Michaela to point B. And so that would be, new angle is 31 degrees. It's still tangent because we have the opposite. The opposite is still this height of the plane, of the altitude, which is 5,750 over, I'll call it y to find this. So y is going to be 5,750 divided by tangent of 31, which is 9,569.6. So we found this, and we found this, and now we subtract. And it should be 10,483. It says nearest foot. Okay, so really take your time, figure out what the triangle looks like in relation to the ground, the altitude, angle of elevation, angle of depression.